To help us move towards percentiles, I'm not going to go in a lot of detail on the percentiles that the book has. You can read the section on percentiles in the book. I actually want to develop another tool that's going to help us get to percentiles in a deeper way, which is called the standard score. Or z-score. And you'll hear me say z-score. My wife is English. My kid's kind of half American, half English. English. This is the letter Z. And I still have a habit of saying Z. If you get confused, it's the z-score. It's the z-score. And what we do is the z-score is some value minus the mean over the standard deviation. Or x minus mu over sigma for a population. We're talking about a sample, x minus x bar over s. And what this does is, remember, standard deviation has the same unit as the variable of interest. And so like a coefficient of variation, this measures unitless. The units cancel out. So let's say my variable of interest was measured in, we'll be doing pounds. That means my mean would be in pounds, and my standard deviation would be in pounds. So pounds in the numerator and pounds in the denominator, they cancel out, meaning z-scores have no unit. And what they help us do is they actually talk about how many standard deviations away you are from the mean. So if this is the mean, and I have one piece of data over here, we'll say this is x1, and so the z-score for z1 is x1 minus the mean over the standard deviation. Well, this would be positive, and it would tell me how many standard deviations I am from the mean. So it becomes a measure of position using the standard deviation as your measuring rod. So again, I'll go to an example in the book here. The mean speed of vehicles. So the mean speed of vehicles around a stretch of highway is going to be, let's say the mean speed on a stretch of highway, this is 56 miles per hour. With a standard deviation of 4 miles per hour. We grab a sample of 3 cars, car 1, car 2, and car 3. And we find that first car is 62 miles per hour, second car is 47 miles per hour, and the third car is 56 miles per hour. And what we can do is we can find 3 individual z-scores. The z-scores line up with the piece of data. And so z1 is x1 minus the mean over the standard deviation, or 62 miles per hour minus 56 miles per hour over 4 miles per hour, which is, running to my calculator here, a z-score of 1.5. So notice that's positive. Z2 is x2 minus the mean over the standard deviation, or 47 miles per hour minus 56 miles per hour over 4 miles per hour. And going to my calculator here, negative 2.25. Notice no units either. And Z3 is x3 minus the mean over the standard deviation, or 56 miles per hour minus 56 miles per hour over 4 miles per hour, or a z-score of 0. Now what this does for me, let's see if I can scroll down just a bit here. I'll do it over here. I'll do it in yellow. Yellow goes well with blue. Is my mean is here. And so Z1 is 1.5 positive standard deviations away from the mean. And so I come over here and there's Z1. I know where it's at. This is 1.5 standard deviations away from the mean. Z2 is negative 2.25, so it's over here, further over here, negative 2.25. And Z3 is 0, and so Z3 is right on the mean. And so Z scores become a way of telling your position relative to the other pieces of data and relative to the spread of the data. Because it uses the standard deviation, and we know from the empirical rule that 68% of the stuff is within one standard deviation on either side, this is telling you where this falls in onto an idea of percentiles. And the Z-score is going to be one of our most powerful ways of looking at the data we have, because it gets rid of anything outside of the spread. And we can say, a little rule of thumb here, is anything within 2 standard deviations is usual data. Anything between 3 standard deviations is unusual. And anything greater than 3 is very unusual or rare. And so we have a way of actually now comparing pieces of data to where they fall within our collection of data. And this is really going to be the tool that we exploit. It comes back very, very, very strongly in Chapter 5. The only thing we have to do now that we have all our description together is we have to automate this. And so we have ways of describing our data and putting numbers to it and telling us, how narrow our collection of data is, where the middle is, and where our individual pieces of data are within our data sets.